Hello everyone. First we are discussing about the advantages and disadvantages of the vane pump and followed by the piston pumps. The advantages of the vane pumps are the vane pumps are self-priming, which is same as that of the gear pumps. Even in the gear pumps also, either it may be a external gear pumps or it may be a internal gear pumps. Normally these pumps are the self-priming only and which are robust and the supply of the constant delivery at a given speed. They provide a uniform discharge with a negligible pulsation. The negligible pulsation in the sense the output discharge is constant for the particular speed. The vanes can be replaced very easily once if there is any wear and tear in the veins, and also if there is any damages with respect to the veins, that it can be replaced. These pumps do not require a check valve. They are light in weight and as well as compact. They can handle the liquids containing even the vapors and as well as the gases. The volumetric and as well as overall efficiency of the vane pumps is higher when compared to the gear pumps. The discharge is less sensitive to change in viscosity and as well as the pressure variations. The disadvantages of the vane pump. The relief valves are required to protect the pump in case of the sudden closure of the delivery. They are not suitable for the abrasive liquids. If the liquid consists of the contamination or it may be some abrasive materials, the wear and tear it will take place between the veins and also the casings or the cam ring. Then automatically the veins get damaged. Once if the veins get damaged, the required pressure it cannot be maintained, and even the discharge is also uh, not uniform. They requires a good seals. They are good. They need a good filtration system, and the foreign particles can severely damages the pump. The next part what we are discussing is with respect to the piston pumps. The piston pumps are the pumps which are working on the principle of the reciprocatory motions. The reciprocatory motion is converted into a rotary motion. According to the piston and the cylindrical block, the driving shaft and as well as the piston pumps are classified as the swash plate type piston pumps, bend type piston pumps, radial type piston pumps. According to the basis of the displacement, the piston motors are classified as the fixed displacement piston motors and as well as the variable displacement piston motors. The first one what we are discussing is with respect to the axial piston pumps. In the case of the axial piston pumps, the piston reciprocates parallel to the axis of the cylindrical block. These motors are available with both fixed and as well as a variable displacement features. They generate the torque by the pressure acting on one end of the piston reciprocating inside the cylindrical block drives the shaft, and the cylindrical block are centered on the same axis. The pressure acting on the one end of the piston generates the force against an angled swash plate. This causes the cylindrical block to rotate with a torque that is proportional to the area of the pistons. The torque is also a function of the swash plate angle. The inline piston motors is designed either for the fixed and as well as the variable displacement units. The swash plate angle determines the volumetric displacement. The schematic diagram shows the swash plate type piston pump. See, the swash plate type piston pump consists of the cylinder. The cylinder consists of the reciprocating piston. The reciprocating piston insert connected to the swash plate through the rod. The center of the swash plate and also the center of the cylinder, both it lies on the same straight line. In this type, the cylindrical block and the driving shaft are located on the same center line. The pistons are connected to the shoe plate that bears against the angle swash plate. As the cylinder rotates, the piston reciprocates because of the piston shoes followed by an angle surface of the swash plate. The outlet and the inlet port are located in the wall plate so that the piston passes the inlet as they are being pulled out and passes the outlet as they are being forced back in. This type of the pumps can also be designed to have a variable displacement capabilities. The next one is nothing but the bend type piston pumps. The construction consists of a cylindrical block with an array of the cylindrical openings, housings, pistons, and a driving shaft. The housings is designed in such a way that it creates an offset angle between the center line of the driving shaft and the center line of the cylindrical block. The pistons are connected to the driving plate with a ball and a socket joint. This type of motors develops a torque due to the pressure acting on the reciprocatory piston. In this motor, the cylindrical block and as well as the driving shaft motor at an angle to each other so that the force is exerted on the driving shaft of the flange. The speed and the torque depends upon the angle between the cylindrical block and also the shaft. The larger the angle, the greater the displacement and torque, the smaller the speed. The angle is varying from 7.5 degrees to 30 degrees, a maximum. These type of motors is available of two types. Either it may be a fixed type displacement or it may be a variable type displacement. A schematic diagram shows the bend type piston motor. The left side is nothing but a cylinder. The cylinder is in turn connected with the piston. The piston is in turn connected through a rod and also the ball and socket joint. The ball and socket joint is connected to the shaft. As the piston starts reciprocating inside the cylinder, the shaft starts rotating it. This rotary motion transfers the power. Next, the pump performance. The pump performance or the performance of the pump is a function and as well as a precision of its manufacture. An ideal pump is having a zero clearance between the two meeting parts. Since this is not possible, the working clearance should be as small as possible while maintaining a proper oil films for the lubricating between the rubbing parts or it may be a mating parts. The performance of the pump determines the efficiency of the system. The first one what we are discussing is nothing but a volumetric efficiency. Volumetric efficiency is defined as a ratio of the actual flow rate to the theoretical flow rate. It is expressed in terms of the percentage. The volumetric efficiency indicates the amount of the leakage that takes place within the pump. This is due to the manufacturing tolerances or the flexibility of the pump in the casing between in the design, the pressure operating conditions. The gear pumps will have the efficiency somewhere around 80 to 90% and the vane pump is having somewhere around 92%, but the piston pumps is having the volumetric efficiency some 90 to 98%. The mechanical efficiency. Mechanical efficiency refers to the ratio of the pump output to the actual power input. Even this also it is expressed in percentages. The mechanical efficiency of the pump is due to the energy losses other than the leakages. The overall efficiency. The overall efficiency refers to the overall performance of the pump considering the possibility losses including either it may be the leakage losses or it may be the frictional losses or some other losses. It is defined as the ratio of the actual power output to the actual power input.